Please welcome Bénédicte Men, Oxford University Innovation.
Hi everyone and greetings from Oxford. My name is Bénédicte Men. I'm a Senior Investment Manager at Oxford University Innovation, the technology transfer office of the University of Oxford. So Oxford nominated FluoRok for the Falling Walls Science Breakthrough of the Year competition in the Science Startup category. Why? Because FluoRok is solving one of the largest hidden problems in industrial chemistry. Their proprietary technology replaces hydrofluoric acid, one of the most dangerous substances in industry, with a safe, scalable alternative. The company therefore enables cleaner, more sustainable manufacturing of vital materials for batteries, pharmaceuticals, and agrochemicals. FluoRok is not just innovating, they're reshaping a $24 billion global market. FluoRok is a scalable solution to a critical global challenge and is a true example of science-driven entrepreneurship. So thank you all for listening and enjoy FluoRok's presentation.
Breaking the wall of fluorochemical manufacturing. Gabriela Pupo, FluoRok.
What do these four pictures have in common? It's only one reagent and one reagent only, which is called hydrogen fluoride. It is toxic, it is dangerous, it is hard to handle, it is extremely corrosive. Yet the world, and we've asked, why don't we just ban it and stop using it? There's a very simple answer, that there is no alternative to access chemicals that contain fluorine. Or as I like to say, there was no alternative. FluoRok is rethinking the way we access fluorochemicals in a safer, greener, lower cost, and localized way. But first of all, where do we have fluorochemicals? You actually have them in your pocket. They are present in this room with key applications in lithium-ion batteries, inorganic fluorides, so chemicals industry, up to 30% of agrochemicals and pharmaceuticals of the world, as well as application in refrigeration, fluoropolymer, huge market opportunity, yet they are made with one of the nastiest and most problematic methods that the world has ever seen. Where do we get that? Go back to 1771, when a Swedish chemist suggested using fluorite mineral or calcium fluoride treated with acid under extreme temperatures to make hydrogen fluoride. We move to 2025, what do? We take fluorite mineral, we add acid, and we make HF. Exactly the same process 250 years later. And HF is at the center of the supply chain and unchanged, and really everything has to go through it. FluoRok rethinks completely this process, and for the first time in the world, we are able to access fluorochemical in a completely HF-free. But not only, we also do not rely on the mined material, as I mentioned before, but we are able to use recycled material that comes out of waste streams of adjacent industries. So we use waste, we don't use HF, and we're able to make fluorochemicals. Now, how do we do this? We basically combine this fluoride with a phosphate. We use a base instead of an acid, the exact opposite of what everybody does to activate it. We apply mechanical energy and we get a new powder. That new powder is now at the center of the supply chain of FluoRok instead of a really dangerous, extremely toxic gas that was HF. And we really more focus into traditional chemical manufacturing rather than a high hazard like the HF industry is doing. Now, where do we apply this? For a platform technology that really has the potential to change an entire sector, we focus on high growth areas. In particular, lithium-ion battery electrolyte salts. The key component of a lithium-ion battery, anode, cathode, the salt that carries the charge, is called lithium hexafluorophosphate. It's currently in your pocket, in your laptop, right in front of you, because it is that salt that carries the charge between the two. How much are we going to need in Europe by 2030? In Europe and US, 170,000 tons. How much do we produce currently in the Western world? It's a very easy number to remember because it's zero. Everything is dependent on imports. Why? Because it's extremely challenging, for example, in a European context, to employ the current technology to develop this. How can FluoRok really solve this? By really slashing the capital cost, by improving sustainability, and the costs are really related to the fact that we get rid of that really toxic chemical and really provide a supply chain, localized supply chain, to allow development of lithium-ion battery and pushing decarbonization. We already have more than 200 million revenue stream pipeline, both in terms of offtake requests for lithium PF6, as well as strategic partners from some of the largest chemical companies in the world, with all of our reagents validated, both the reagent part and the lithium PF6 itself, which has been put in batteries and has the same performances that you would expect from the market. And where are we on our path? We have already secured more than 10.7 million pounds in equity and more than 3 million, actually this is not even updated, it's actually now 4 million, in grants. And we are at a scale in which we are at a pilot stage. In 2 years and a half, we have developed from proof of concept to pilot stage multi-kilogram production facility for both our reagents and the critical lithium-ion battery electrolyte salts. We're now out for a Series A funding round to develop our demonstrator scale. That means that we move into the multi-ton production of chemicals, and the last step before the commercialization phase from 2028 for mass adoption and more on the thousands of tons of production. All of this is delivered by an incredible team of extremely talented scientists, engineers in operations, in business development, with a lot of knowledge both in fluorination, tech scaling, commercialization of chemicals, and fantastic investors that have really supported our journey and really believe in our mission to rethink chemical manufacturing towards a safer, greener, lower cost, and localized production of chemicals. Thank you.
Time is a science. I told you this was really on point. Great. Are we ready for... Yes, okay, let's go. First question here.
Yeah.
Then we will go to Iris.
Thank you, great pitch. I see the point with inorganic fluorine-containing materials, but can you also handle organic materials? Does it work as well?
Yeah, so actually the interesting part of it is that the technology is platform. So once you access your key central reagent that is derived from the calcium fluoride, you have the potential to access potentially any chemical. In practice, we have focused in specific areas. Some of the organic, for example, all the building blocks for pharmaceuticals and agrochemicals, we can access, absolutely. In other areas, we haven't put our focus in, but we really believe this platform technology has the potential to access anything that you can think of in the market. And it's really the technology of, the 21st century.
Next question by Iris, please.
What infrastructure changes do your customers need to make if they adopt your product versus HF-based processes?
Yeah, it's a completely different one. And this is why we go after growth markets. So places where you actually need to put in new capacity. So they're going to have two options. Do I use the old technology, very dirty, much more expensive, or do I use a new technology that is really completely rethinking of it? So there isn't really this need to rethink and use fully depreciated assets. So we don't even make that comparison, basically.
Mm-hmm. Next question, Andrea, please.
Hi, great pitch. What's about competitors?
Competitors, excellent question. The competitors are the actual status quo, because to the best of my knowledge, there isn't anyone else on the planet that has a technology that can access fluorochemicals, not only HF-free, but also by using low purity materials like the one that we do, where we really use recycled materials, low purity, and turn it into battery grade materials. So the competition comes from the current HF technologies, but we have a platform that would be competitive even with Chinese imports that would come, for example, for the lithium-ion battery materials.
Mm-hmm. Next question by Cyriac, please. Oh, I don't know where the microphone is yet. Sorry.
Thanks. What are the biggest risks that this might fail?
It's an excellent question. So we've been trying to de-risk it at every single step.
The scalability especially.
That on the scalability part is the part in which we have moved little by little in terms of scaling to make sure that we don't miss anything and we don't run before we are able to walk, as you usually say. We have considerably removed the scientific risk, which is where we are at this point, and we are now moving into the scaling part of multi-ton production. But critically, the pilot facility has really indicated confirmed how all the unit operations are actually the correct ones that we are going to scale. So we have mitigated that as much as possible. But as always, as a scientist, until you actually have a multi-ton production, I will not be able to tell you that the risk is always zero. That's just what it is. You have to build it.
For the next question.
Perfect. Thank you very much. So how do you make money? Is it only for the output or also for the input? Because you talked about using waste. So is it also a revenue stream?
So it's actually a potential revenue stream. We tend to be conservative and think of the recycled or low-grade materials are up to 50 to even 50% cheaper than the mine material, or even 10x cheaper potentially. So there is that potential revenue stream. Most of the business model relies on the manufacturing of the actual output of the product. And then once at scale, we actually have a business model that includes licensing so that partners can actually build even larger scale plants once we have our first of a kind, basically, which is expected in, from 28 onward.
Yeah, we have 20 seconds, Stefan.
Okay.
so-
Can you tell the science secret in your patent?
The science secret, you can probably look it up on the patent, but
10 seconds.
from a scientific point of view is that you just don't have that really dangerous intermediate that really raises your cost when you're actually looking at a simple chemical reactor.
Yes. I'm sorry, but we are over the time. I'm very sorry.
I'm very
I need to
happy
be
to
fair to everybody. Yes, you
Thank you
can
very much.
definitely go on with that.
Thank you.
Thank you so much.